these are all going to be solids. So solids is kind of like a 3D, it's a 3D figure. So it's going to have, normally we just have a width and a length when we see figures, but now we're going to also have a height. So it's going to be where you can't see the entire thing, and that's why there's some dotted lines in there. Okay, so I'm going to give this definition again in a little bit here. A prism, we're going to be talking about prisms today, prisms and cylinders. So a prism is a polyhedron, and I'll give you that definition later as well, with two congruent parallel faces called the bases. So the two that are parallel, in other words, the two shapes like these two pentagons that don't touch, those would be your bases. So this picture can also be turned on its side. So the bases can either be the top and the bottom, the left and the right, it doesn't matter, but they are parallel and they'll never touch. You also have lateral faces. Those are all the other sides. Okay, and then a prism, we usually name it by the shape of its bases. So this kind of thing, the bases, since it's a pentagon, it'll be a pentagonal prism, kind of something like that. Okay, and then the other one, since the triangles are the bases, triangular prism. Okay, now the important part is you need to be able to find the height. The lateral edges, those aren't that important. That's just saying it's basically an edge. So the height, we're going to have to be able to find the height of these prisms. It's going to be the altitude. So if it already has a right angle, then that can be the height. So these two are easy to find. So the important thing about the height is that the height is going to join the bases. So it joins the planes of the bases. In other words, it's going to be touching both of the bases. So this, in a cube, anything can be the base because these are parallel and these are parallel, so it didn't matter. In this one, you've got trapezoids. So your height has to touch both of those bases. So it touches this trapezoid, and it's at a 90-degree angle. If it's not a 90-degree angle, you'll have to kind of have a dotted line out here. So this would be the height. This is not considered part of the base. This is just to kind of extend it, because the altitude or the height has to be from the lowest point to the highest point, and it has to be a 90-degree angle. So that's the only difference with those kind. So I said I'd tell you what a polyhedron is. You probably know it from science, I'm assuming, but it's going to be a 3D figure whose surfaces are polygons, just meaning it can't be circles. So these are the 5 shapes that we're going to be doing over the next couple of weeks. Today and tomorrow is just prisms and cylinders. So a cylinder is not a polyhedron because it's got a circular base. Okay, so the surfaces have to be polygons. Polygons can't have any curves, no crossings, and no openings. So a polygon is just a normal closed figure. Okay, and then so cone cannot be a polyhedron, sphere can't be, but a pyramid is. So a pyramid's a polyhedron. All of these, the 1, 2, 3, 4, 5 pieces, the 5 polygons in there, those are all polygon shapes. Same with the prisms. So with this prism over here, I've got triangle, triangle, rectangle, rectangle, rectangle. So all of its faces, all of the surfaces are polygons. Okay, a prism, these are the 2 that we're dealing with today. So we'll worry about the other 3 later. So a prism, it looks like this. It can be a couple different kinds of figures. It can also be a cube. So it's just a solid where the 2 end faces, which we already called the bases, they are parallel and the sides are parallelograms. So with the sides have to be parallelograms, meaning rectangle, square, rhombus, things like that, all those things that we learned. And a cylinder just looks like a can. That's why I put a can right there. So that's what basically a cylinder is. It's a can of soup. So it's a solid where the 2 end faces are circles. Those are the bases. And then the body is just this curved kind of surface. So on your formula sheet, I don't know why they give you a cube and they give you the different vertical or volume and surface area. I would just ignore this one because it's the same thing. It is a prism. So this will work for it. You can use either one. So if you get a cube, you can use this one or you can use this one. Both of them give you the same thing. I rather just have less formulas. So I'd rather just work with this one. I will give you a formula sheet for quizzes and tests for this. So, you don't have to worry about that, but I would copy these down so that you have them for your notes so you can practice them. So we're going to work with this today. Volume is going to be tomorrow, so I'm not worried about volume. Lateral area, the lateral area is just kind of the area that's on these parts, on the faces, instead of including the area of the bases as well. So if you notice, the lateral area is part of the surface area. But this is what we're going to be working with today. the volume is what you're going to be working with tomorrow. Okay, but they give you all three formulas just in case if they ever ask you for lateral area. That's all they want. So I've got two different ones here. I've got a normal, nice and easy one, and then one that's more difficult. So with this, for my surface area, we got to figure out what all these letters mean. So for these things, I'm going to do the height for the H, and then the P is going to be perimeter. I put the R in the wrong spot. You get what I mean. Ignore that. And the capital B is going to be the area of the base, not just the base. So that'll be area of the base. So it depends on what your base is. In both of these, my base is, if you notice, the triangle on top and the triangle on bottom, dotted line, you can't see it. Those are your bases. So for the 2B, I'm going to have to find the area of the base. That's what makes this one harder. I don't have the height of the triangle. So that's the only reason why that one's going to be more difficult. Otherwise, it's the same thing. So I need to do the height. Remember that the height connects the two bases. So the ones that are connecting the two bases are either this one, or this one. And they gave me that one as 8. So that is my height. And then my perimeter. I'm supposed to be finding my perimeter of the base. So you may want to throw that in there. So you want the perimeter of the base for that. So the perimeter, I've got 5, 12, and 13. So maybe leave yourself a note, 5 and 12 and 13. So that's 10, 20, 30 for my base. Or for my perimeter, sorry. And then I've got plus, and I've got 2 times the area of the base. So the area of the base is a triangle. So it's going to be 1/2 times your base times your height. So your base and your height are going to want to be the ones that make up that right angle, if there is a right angle. So 1/2 times 5 times 12. I can't put my 12 in there. Okay, so the 1/2 and the 2, if it's a triangle, those are just going to go away. So really all I got is 5 times 12 right here, which is 60. And then 8 times 30, which is 240. So my total surface area is going to be 300. And since it's still area, it's square centimeters. Okay, so basically what you are doing is you're finding the area of this rectangle, of that rectangle, of the rectangle you can't see in the back, and then of these 2 things down here, of the 2 triangles. That's what surface area is. It's every surface, and it's the area of each of those pictures. Okay, down here, what I want for surface area in this second one, I need the height. So the height is going to connect my bases. In this case, my bases are these 2 triangles. So my height can be one of those 3 lines, and they gave me 10 for my height. And then I need my perimeter. So that means I need to find this one as well. So not just to assume that it's an 8, but you can use this to show that it's 8. So since that's there, opposite sides of a rectangle, this rectangle, opposite sides are equal. So if that 8 wasn't there, I'd have to do a little work using SOHCAHTOA or special right triangles to find it. Don't just assume. So 8, 8, and 8 is 24. And then I've got to do plus 2 times my area of the base. And that's where it's a little bit difficult. I'm going to have 1/2 times the base times the height. So what I need to do is, since these 2 sides are equal, that means these 2 angles would be equal in a 45, 45, 90 degree triangle. So that is also going to be 45, 45, 90. Okay, in here. So if this is my Z, we still have to do those. If you don't want to do the Z's, a lot of people are using SOHCAHTOA. That is fine with me. The only issue is if they ask for an exact answer or if they ask for radical form, that would be your only issue. So if you're doing this, this is going to be Z squared root of 2. You would have to rationalize. So I'm just going to show it with SOHCAHTOA just to, because that's what most of you guys like to do. And this one will just be round to the nearest 10th anyway. So pick one of the 45s. It doesn't matter. Just don't use the 90. So I need the opposite, and I have the hypotenuse. So that means I'm going to be using sine. So the opposite is missing. The hypotenuse is 8. So if you do 8 times the sine of 45, which I don't have my calculator out. That's going to be about 5 point, and make sure you use at least 3 decimals, if not 4. I would go with 4 just in case. So for this, my height is 5.6569. Also, if you're going to use the 4th decimal, round it. Use that next one to round that up. So that's going to be my height of the triangle, and my base of the triangle is going to be the 8. So it's going to be times 8 times that 5.6569. I just use the same decimal. When I put it in my calculator, I just keep that long decimal in there to make sure that I have it accurately. So I just leave the long decimal in there, and then I do my calculations with it. You can like paste or highlight it and enter it, and it'll work. So what I'm going to do is just type everything else in there. So I've got times 8, and I don't need to worry about this because 2 times a half is just 1. So I don't even need to worry about that. And then I'm going to add the 10 times 24. And I'm going to get 200. Now I can round to the nearest tenth that I got my final answer. I got 285.3 inches squared. Okay. So that would probably be one of the harder ones. And then down here, we're just going to do a couple of different areas. So I rewrote it again. So we're looking at the surface area right there. This is the formula I'm using all day today. So when it's a cube like that, again, you can use that other formula that I provided for you earlier. Just think it's easier to use this one. So my height, we'll just call this my height. If you think the top and the bottom are your bases, 5 is your height. If you think the left and the right are your bases, 5 is still your height. So it really doesn't matter. And then I need my perimeter. So 5, 4, 5, and 4 is 18. And then 2 times the area of your base, which since it's a rectangle, it's just going to be 5 times 4, which is 20. I think that's a lot easier than all that stuff they put up above. Plus, it's only one formula that you have to memorize. So you got 5 times 18, and then plus 2 times 40, which is going to give you 130 inches squared. Okay. Up here, the next one, my bases are these trapezoids right here. So first of all, for my surface area, I've got to do my height. My height's going to connect them. So it's going to be these lines. And they give me one right there is 12. That's my height. And then I need my my perimeter. So my perimeter, I've got 2.8. This 8.1 is the opposite in a rectangle of this 8.1. So this rectangle means opposites are equal. So if I'm looking for my perimeter, I've got 4, 4, 8.1, and 2.8. So I've got 18.9, I believe. Okay, so that's my perimeter, and then I'm doing plus 2 times the area of the base. So area of the base, that's what this 3 is going to be for, because that's going to be my height of my trapezoid. Area of a trapezoid is 1/2 times height times the sum of the bases. So 2.8 and 8.1. So this is all going to work out. I've got 2 times 1/2 just goes away. So if that happens a lot, if you use 1/2, that can just go away. It didn't happen over here because I had a square. It didn't have a half in it. So I've got 12 times 18.9 plus 3 times, and then in parentheses, 2.8 plus 8.1. So that's going to give me about 259.5. And that is units squared, since they didn't give me anything. Okay, I'm trying to give you a different kind of picture for each one. 13, this one down here, I threw this one in here because it's a difficult one. The reason it's difficult is because the stuff we learned last week, to find the area of a regular octagon, we have to do a little work for it. So first of all, surface area, I've got my height, which is going to connect the 2 octagons. So the 22 is my height. Since it's regular, all the sides are equal. So 5 times 8 is going to give me 40. And then I need to add 2 times the area of my base. So the area of my base, remember what we learned was we had to do the apothem and then times the perimeter. And on my formula sheet, I had divided by 2, but when I taught it to you in the notes, it was 1/2 times. It's the same thing. Okay, so if I'm doing this, I don't have my apothem. I do have my perimeter, though. My perimeter, we just talked about it, was 40. So for my apothem, I have to do all this fun stuff. Okay, so you got to do 360 divided by 8, which is 45. And then remember that the apothem cuts that in half. This is all the stuff we were doing before. So that's going to give me 22.5 right there. Okay, the bottom is 5, so this will be 2.5. And then I need the apothem right here. So to do that, I'm going to use SOHCAHTOA. Opposite, adjacent, means I'm going to be doing tangent. So opposite over adjacent. Now, when you have the missing on the bottom, you just swap these. So I'm going to be doing 2.5 divided by the tangent of 22.5, which is going to give me about 6.0355. Okay, so that is going to be my area of my bases. So I've got the 1/2. Again, that's going to go away. So I can just really times that by 40. Come on, pen. And then that's going to end up giving me 241.4214. Okay, so this is the area of my base. And then I'm going to add 22 times 40 to that. So my final for this one is going to be 1,121.4 centimeters squared. And then that's the hard part. The cylinders, easy peasy for the cylinders. So I'm doing this one, these end ones are really quick. So again, volume we'll do tomorrow. We got lateral area, surface area is what we're looking at today. So the reason why it's so easy is there's no getting around it. All you need is your height, which again, the height's going to connect the bases, so the 12 in this one. And also you need your radius. That's all you need. And they always give it to you. They always give you all the things you need. So for my surface area, I've got 2 pi times the radius. Radius of the circle is 3. Plus 2 pi radius times the height. And the height, again, is going to connect the bases, which are the circles, so the 5. Okay, this one doesn't say anything in the directions. I'm going to round it to the nearest tenth. Down here, this means something different. That's why I put 2 more at the end. So I've got 2 times 3 times pi, and then plus 2 times pi times 3 times 5. So that's going to give me a total of about 113.1 centimeters squared. So cylinders are much easier. Okay, next one, 2 pi radius, which would be 5. That's the only tricky part they'll do to you is they'll give you the diameter. I sure forgot the squared. Let me do that again. So 2 pi times 9 plus 2 times pi times 3 times 5. Sorry, scratch that because I forgot that squared. So this is 150.8. Okay, so I've got 2 pi r squared plus 2 pi r height. So that's all we're doing. So 25 times 2 times pi plus 2 pi 5 times 12. So this one will give me a total of 534.1 meters squared. Okay, so when you're just rounding to the nearest tenth, you put it all in the calculator. Now down here, the only difference is they want it in terms of pi. So when you see that terms of pi, that means when you get your formula, so my surface area is 2 pi r squared plus 2 pi r height. So when you are plugging this in your calculator and they want it in terms of pi, that means do not put these in the calculator. So right here, 2 squared is 4 times 2 is 8. And down here, 2 times 2 is 4, and 4 times 8 is 32. So you just plug in 2 times 2 times 8. You just plug in the numbers. Forget about the pi's. The pi's are just coming along. So you're not putting them in the calculator. So all they want for this one is 40 pi. I guess this is easier to do. You can just do it in your head instead of using pi because it's a lot harder to multiply 3.14 decimal forever. Okay, so terms of pi means don't plug the pi in the calculator, just bring it on down to the end. Same thing here. So I've got 2 pi r squared because the radius would be 1.5, and then plus 2 pi r times the height. So this time I'm plugging that in. 1.5 squared times 2 is what I'm plugging in my calculator. So then that's going to give me about 4.5 pi. And then here I'm going to type in 2 times 1.5 times 4, which is just going to give me 12. Whoops. Go away. So that's going to give me 12 pi. Now, if I add those up, that's going to give me about 16.5 pi centimeters squared. So pay attention whether it says terms of pi. Sometimes it'll say exact. So when it says exact answer, that means they want you to do it in terms of pi. So sometimes they'll say that in, what's it called? IXL. Okay.